Hello and welcome in this video on the arithmetic progressions. In fact, it is our third video on the same topic, which is an arithmetic progression, that is AP. Okay, and in this video we are going to discuss about the sum of n terms sum of n terms of an AP. Okay, so suppose we are having the first term, let A, and this A is the first term of the AP, and D is the common difference of the AP. And suppose we need to find out the sum of n terms. Okay, we are using the general formula, so let us assume that we have to find out the sum of n terms. Okay, n terms. So let us represent this sum of n terms by Sn. So it will be n by 2 2a plus n minus 1 into d. Here this A is the first term and D is the common difference, and n is the number of terms of which we are finding the sum. Now we can obtain another form of this formula if you write this 2a, if you break this 2a as a plus a. So this 2a can be break it like a plus a, and we are having n minus 1 into d. So this will give you n by 2 a, and this a plus n minus 1 into d. So this is your nth term, means an. So this is a plus an multiplied by n by 2, and this is again the sum of first n terms of an AP. Or you can also say that if you are having the information of the first term and the common difference, and let's say L is the last term. Okay, L is the last term of the AP, then, and if you have to find out the sum of all the terms of an AP whose first term is A and the last term is L, then the sum will be n by 2 a plus L. So here we don't need if you are having the information, or if we are at the values of a and L, so we do not need D here. Okay, so we are not requiring, or we are not using the common difference. But this is the case when you are having the value of the last term and you are finding out the sum of all the terms of AP. Okay, so now let us discuss some problem on this formula. So let us take the problem, and the first problem is how many terms of the AP. So we are having this AP 43, 39, 35 and so on be taken show that their sum is 252. Okay, so this is our first problem. So in fact this is a different type of problem where you are already provided with the sum and you have to find out the number of terms which have been added to get this sum. Okay, so again, so let us begin with the solution. So we are given we have to begin with the given information. So we are given that this AP as 43, 39, 35 and so on. So we can easily find out the common difference D, and we know that it is the difference between any two consecutive terms. So let us consider this as 39 minus 43. So this is coming out as minus 4. And we are also having the sum. So let sum of n terms is 252, and so we have to determine this value of n. Okay, so now we are using, and also okay, before we use the formula, so we are also having the first term which is 43 here. Okay, so now we are using the formula of Sn, which is n by 2 2a plus n minus 1 into d. So now Sn we already have with us, so it is 252, and the value of n we have to determine, and 2a, so it is 2 into 43, so that is 2 into 43 plus, again we are not having the value of n, we have to determine it, and the value of d. So from here you will get, if you multiply this 2 here, so this give you n times, so I am writing the right hand side here first, so this is 86 minus 4n, because you are multiplying this n minus 1 by minus 4, so if you multiply, so this plus and this minus will become minus, and again this minus and this minus 1 will become plus. 4 is equals to 504. Okay, so we are getting this. Now if you multiply it, this bracket with n, or first we have to simplify it further, so you are having minus 4n, and 86 plus 4 is coming out as 90 is equals to 504. Even you can further simplify it as if you take 2 common from here, then you can easily cancel out this, so you can easily obtain 2 times n. I am taking 2 common from here, so this is minus 2n plus 45 is equals to 504. So this implies minus 2n square plus 45n is equals to 252, because you can take this 2 towards the right hand side, so we are having 504 divided by 2, so it is 252, and this further gives you 2n square minus 45n plus 252 as 0. So now this is a quadratic equation, and we know that quadratic equation has two roots, means we will get two values of n. So we can easily factorize it. So we can write this as 2n square minus, you can write this as 24 plus 21n plus 252 is equals to 0. So this will give you 2n square minus 24n minus 21n minus 252 is equals to 0. So from here you will obtain as you can take this 2n common, so you are having n minus 12, and from your second bracket you are having 21 as common, so this is n minus 12, okay, is equals to 0. So you can write it as n minus 12 and 2n minus 21 is equals to 0, which gives you two values of n as 12 and 21 by 2. Okay, so it is clear that we cannot take this 21 upon 2 because we are having number of terms. So this implies the number of terms for this AP, which gives you the sum as 252, is 12. So now let us take another problem on this formula related to the sum of n terms of AP. So now take a simpler one. So here in this problem, find the sum of first 20 terms of the AP, and the AP is given as 5, 8, 11, 14 and so on. Okay, so we are given this AP. So now let us discuss the solution of this problem. So again we first note down what is given to us. So we are given A is equals to 5, and we can easily find out T by subtracting 5 from 8. So this is coming out 3, and the sum of first 20 terms which we have to determine, so it means the value of n is 20. Okay, so the value of n is 20, so we have to determine as 20. So that will be n by 2, so that will be 20 by 2, 2a, so that is 2a plus n minus 1, n means 20 minus 1 into d, so this is 3, and this will give you 10, and this 2 into 5 is again 10, plus here we are having 20 minus 1 which is 19, and 19 into 3 is 57. So this is 10 into 57 plus 10 is 67, so this is coming out as 670. So the sum of first 20 terms of this AP is 670. Okay, now moving ahead, let us have another problem on this sum of n terms of an AP. So here we are given a problem. So we have to find the sum of the first 51 terms of the AP whose A2 is 2, means the second term is 2, and A4 is 8. So here, as you can see that in this problem we are not having the value of A, means the first term, and the value of D, means the common difference. But again, we are having these two information to determine the values of A and D. So again we start with the given information. So we are given A2 is equals to 2 and A4 is equals to 8, and of course the value of n is also given to us, means we have to find out the sum of 51 terms. So the value of n is 51. Now we know that A2 can be written as A plus D. So the value of this second term is 2. So let us mark this as equation number 1. And A4 can be written as A plus 3D, and the value of this is 8. So mark this as equation number 2. Now if you are subtracting equation number 1 from 2, so this will be A plus 3D minus A plus D, and on the right hand side we are having 8 minus 2, which is 6. So from here you will obtain 2D is equals to 6, which gives you the value of D as 3. Okay. Now using this D is equals to 3 in, let's say, equation number 1. So we are having A plus 3 is equals to 2. So this gives you the value of A as minus 1. Now we are having the values of A, D and N. Okay, so N is also given here, means we have to find out the sum of 51 terms of this AP. So now we are using the formula of n, sum of n terms. So S51 will be n by 2, it means 51 by 2. 2A means 2 into minus 1 plus n minus 1 means 51 minus 1 into D means minus 1. This is not minus 1. The value of D is 3. Okay, so this is 3. Now this is 51 upon 2, and when you multiply 2 with minus 1, so it is coming out as minus 2, plus 51 minus 1 is 50, and when you multiply this with 3, so it is coming out as 150. Okay, so 150 and we are having this minus 2 here, so this will be 51 upon 2 into, and 150 minus 2 is 148. So from here you will obtain this as 51 into 74 because you can cancel out this 148 by 2, so you will obtain 74. So now this 51 into 74 is coming out 3774 or 3774. So this is the sum of the 51 terms of this AP. So if you look at this problem, we are not provided with the values of A and D, but yes, we are having the values of two distinct or different terms. So we use this information and we obtain first the values of A and D, and we will then use the formula of the sum of n terms and we obtain the sum of 51 terms. So from the discussion you can say that we are having the direct problems. Okay, we are having the direct problems. Direct problems means we are having the value of A, we are having the value of D, we are having the value of n, and all we need to do is find out the value of Sn. And sometimes we are having some problem where either we are having Sn, we are having D, and we have to determine the value of A, or we are having the value of Sn, we are having the value of A, and we have to find out the value of common difference. So again, we in this case we have to use the same formula, means Sn is equals to n by 2 to A plus n minus 1 into D, and we will obtain the missing value. Means if we have to find out the A, then we can obtain the value of A, and same for D. On the other hand, another type of problem is where we are having some different terms, means AM is given to us, so we use these from these values. So from these two terms, okay, we have to first determine the value of A and D, and then we use these values here, and we can obtain the sum of n terms. Okay, so this is how do we use the formula of sum of n terms, and we can solve different types of problems. So here we have also discussed here that different types of problem that we may have and how we can approach or how we can solve these problems. Okay, so that's all.